Hello, everybody, and welcome to the map review series. As we spoke about on Friday, you're going to have 6 map reviews, and each one at the end of next week needs to be turned in for them all to be counted towards a test grade. Now, to help you guys with this, I acknowledge that we did this stuff at the very beginning of the year, so it's hard to remember how to do everything. Which is why, on each of these, I provided a notes you can look at to try and find some examples that will help you out. Now, I know that a lot of you threw your notes away, so I post them on Schoology for you to go ahead and look up there. The purpose of this video is to help those who were absent or those who didn't quite understand what was going on to go back and look at this. With that said, let's go ahead and get started. Line AB has endpoints at 5, 7 and 3, 0. It wants us to find the length of AB. Now, whenever we see the word length, that tells us we want to use the distance formula. The distance formula is x1 minus x2 squared plus y1 minus y2 squared. With x1 and y1, x2 and y2 being found within these coordinate points. This would be x1 and y1, x2 and y2. Once I identify what each variable is, we can go ahead and plug it into the formula. We've got 5 minus 3 squared plus 7 minus 0 squared. Which, if I plug exactly this into the calculator, I should get 7.28. So the distance between these 2 points is 7.28. Now, a quick note, on your formula charts or in general, whenever you see this formula, sometimes you'll see these orders here flipped. That doesn't actually change anything. You're still going to end up with the same exact answer. So don't worry if you see that. Don't panic, same type of deal. Let's try example number 2. Find the midpoint of line HK if H is at -5, 3 and K is at 7, 12. Now, I want us to actually think about this. I've got a graph with a point at -5, 3 and 7, 12. And we're trying to find the midpoint. The word midpoint tells us that I'm trying to find the middle of the line connecting these 2 spots, which is going to be a coordinate point. So my answer is not going to be a single number. It's going to be an x value, comma, a y value. Luckily, we have a formula for the midpoint. It goes like this. x1 plus x2 divided by 2. This will give us the x value. And for the y value, it's y1 plus y2 divided by 2. That's going to give us the y value of our coordinate point. And just like before, my x1 and y1, x2 and y2 can be found here. x1, y1, x2, y2. So, if we plug it all in, I've got -5 plus 7 divided by 2. And over here I've got 3 plus 12 divided by 2. Now, on the calculator, you have to enter these independently. Enter this part and enter this part. Or if you want to do it in your head, that's possible too. -5 plus 7 is 2, divided by 2 is 1. 3 plus 12 is 15, divided by 2 is 7.5. So the coordinate point 1, 7.5 would give me the middle of this line HK. Let's try out number 3 and 4. 3 says, what is the slope parallel and perpendicular to the graph below? Now, before we get into what the slope here is, I want to talk about parallel and perpendicular slope. A parallel slope, two lines that are parallel have the same slope. Slopes are the same. Perpendicular slopes are opposite reciprocals. Opposite means you change the sign. Reciprocal means you flip the fraction. So let's look at this example here. Let's first find the slope of this graph here. Remember, slope is rise over run. So to go from P to Q, I've got to go down 1, 2, 3. So since I go down, it's going to be negative rise. And I run 1, 2, 3, 4, 5, 6, 7. Now just a quick note, because the top is negative, I can say the entire fraction is negative. So this is a negative 3/7. So to have a parallel slope, I need to have the same slope as is here. So my parallel slope would be negative 3/7. The perpendicular slope is opposite reciprocal. Opposite means I changed the sign, so instead of negative, it's going to be a positive slope. And then reciprocal means I flip the fraction. So instead of 3 over 7, I would have 7 over 3. My parallel slope and my perpendicular slope. We're going to use that information, actually, on number 4 here. Number 4, write the equation of a line that passes through this point and is parallel to this equation. The formula we're going to use on this is called point-slope form, and you can find it on your formula charts. Point-slope form is y minus y1 equals m times x minus x1. Now in this case, y and x, the regular y and x, these two, are going to stay y and x. They're not going to change. This y1 and this x1, those are going to change based on what my coordinate point is. Because this is x1, and this is y1. So, if I were to plug in the values I would have y minus y1 is negative 8 equals, I don't know my m yet, so I'm going to leave a little space for that, x minus the x1 is 7. All I need now is my m. The m stands for slope. So if I can find the slope of this line here, I can use that as my m. When we're looking at a linear equation like this, the slope is always the piece that is next to the x. So in this case, my slope should be 7 because I want a parallel slope. Remember, parallel slopes are the same. So my slope is 7. Once I have it all plugged in, it's just a matter of solving it out. Let's do a little cleanup first. I've got a negative negative here, and when we've got a negative negative, we can turn that into a big plus. So this becomes y plus 8. The next thing I can do, we see a 7 in front of these parentheses. Whenever I see a number in front of parentheses, my first instinct should be to distribute that inside. Remember, it multiplies everything inside, not just the front. So, I get 7x, because 7 times x is 7x. 7 times 7 is 49. And y plus 8 drops down. Now my goal here is to get the y all by itself. So I'm one step away from finishing. I want to ask myself, how do I get rid of plus 8? Well, the opposite of plus is minus. So I have minus 8 from both sides. And whenever I do this, negative 48 minus 8, because they're both negative, I'm going more negative. So I add them together, 49 plus 8 is 57, and I keep it negative. So my answer is y equals 7x minus 57. This equation here is parallel to the original line and goes through this coordinate point. This type of question is probably the one that's going to give most people the most trouble, and that's okay. It's something that requires a bit of more in-depth thought, but hopefully by the end of this you should be used to this. Example 5. Line segment JK is shown on the coordinate plane. Find the length of JK. Well, I have a picture here, and we see the word length. Like I talked about earlier, on number 1, when we saw the word length, that meant we used the distance formula. The same thought can be applied here. I see the word length, so I'm going to use the distance formula, which is x1 minus x2 squared plus y1 minus y2 squared. I just need to find out what the coordinate points are for my endpoints. Remember, whenever we find the coordinate points, we do x first and then y. The x value of this point is negative 1, 2, 3. And the y value is 1, 2, 3. This is my x1 and y1. Down here, the coordinate point is 1, 2, 3, 4, 5, 6. That's my x value. 1, 2, 3, 4, 5, 6, 8, 9. We went down, so that's going to be negative 9 for my y value. This is my x2, y2. Now that we have that, we can plug it in to the formula. x1 is negative 3, minus x2 is 6. y1 is 3, minus y2 is negative 9. And remember, when we see a double negative, we can change that into a plus. And if we entered this into the calculator, we should get 15 for the length of that line. Let's try number 6. Number 6 is very similar to number 4, except this time we're asking for a perpendicular line. So we have to do something special with our slope. I'm going to start out by writing our formula here. Y minus y1 equals m times x minus x1. So I need to find the variables for x1, y1, and m. x1 and y1 can be found in our coordinate point. So x1 would be 3, y1 would be negative 1. The slope is going to be found here in the original, but we have to be careful. Last time I was asking for a parallel slope, so we would use the same as the original equation. This time I'm asking for a perpendicular slope. Remember, perpendicular slopes are opposite and reciprocal. So I'm going to have to take the opposite reciprocal of this slope here. Opposite means I change the sign, so instead of positive, it's going to be a negative. And then I flip the fraction for reciprocal. So instead of 1 over 2, I'm going to say 2 over 1. And 2 divided by 1 is just 2. So my slope here is negative 2. Once I have all three pieces, simply plug it in. Y minus negative 1 equals, the m is negative 2, times x minus x1 is 3. Do a little cleanup first. What happens with the double negatives? They become a positive. And then anytime we see a number in front of parentheses, our first instinct should be to distribute, which is multiplying. So y plus 1 drops down, Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Last but not least, we want to get y by itself. So how do I get rid of plus 1? We minus 1. Negative 2x remains untouched. 6 minus 1 is 5. And with that, we finish the problem. The line that is perpendicular to the original and goes through this coordinate point is this equation right here. Now what I'm going to do is I'm going to stop here, and I'm going to let you guys try out number 7 and 8 on your own. Look for keywords, try and figure it out. You can also look in notes 1-5 if you need. The last ones I want to cover are on the back. 9 and 10. Number 9 says, if y is parallel to z, so these two are parallel to each other, find the value of x. Now, here we have this angle here, and this angle here. In this course, we've discussed two relationships between angles. Either the angles are congruent, or they add up to 180. So we need to ask ourselves, which of these two relationships apply here? Either you remember which relationship should apply, which is amazing, or we can use our intuition. Looking at these two angles, this is an acute angle, this is an obtuse angle. Do these two angles look like they might be equal to each other? I'd venture to say no, because this is a small angle, this is a large angle. So we can pretty safely say they're not congruent. What that leaves me with is that they add up to 180. So I can say that this angle, 3x plus 7, plus this angle, 10x minus 22, is equal to 180 degrees. And then we solve it out. I see multiple x's, so I combine like terms. 3 plus 10 is 13. X. I also see 7 and negative 22. 7 minus 22 is negative 15. Now let's start moving stuff around. I want to get the x by itself, so I'm going to move the minus 15 to the other side. The way I do that is by adding. And finally, this is 13 times x. So to get rid of the 13, I've got to divide by 13. Which gives me x equals 15. Let's look over here at number 10. Now I'm dealing with this angle and this angle. These two angles are both acute. They look like they could reasonably be the same, and that's because they are. These are called corresponding angles. They're in the same spot. This is the lower left spot, this is the lower left spot. Corresponding angles are congruent. So I can set them equal to each other and solve it out. In this case, I've got x's on both sides, so I need to move all the x's to a single side first. So I'm going to start out by doing minus 6x to each side. 11 minus 6 is 5. And now at the same time as moving my x, I want to move my numbers to the opposite side. So I'm going to move this minus 47 over to the other side. The way I do that is by adding 47. Negative 47 plus 47 cancels each other out. Over here, negative 2 plus 47 is 45. Last but not least, divide each side by 5 to get the x by itself, and we end up with 9. If you have any questions, please feel free to leave them in the comments down below. Otherwise, I wish you good luck with your future map reviews, and be sure to check in. I might be posting more of these.